Okay, now in order to get to be able to talk about the derivative of any kind of polynomial, we need a couple of other smaller rules first, and then we can kind of put all of that together. So these ones are fairly straightforward. Let's look at what happens if you're taking the derivative of a function that has a constant multiplier, or a constant out in front. So in other words, c times some function f of x. We dealt with one like this when we were talking about limits, and we said what happens if you have a limit of c times f of x. And what we said with limits is that you could just kind of pull that c out in front outside of the limit, because c doesn't have anything to do with x, and therefore it doesn't have anything to do with the limit. For the same reason, you can actually pull the c out front with derivatives here, and this becomes c times the derivative of f of x. Okay, so another way to write that, by the way, c times f prime of x. So if you have a constant out in front that's being multiplied, it doesn't actually matter, and it doesn't throw things off for us too much. Now, we can't just say, oh, the derivative of that constant is 0. The derivative of a constant by itself is 0, but if you have a constant times a function, we need to be careful of the fact that there's multiplication there. Okay, and then kind of the last rule before we put all this together and get all polynomials as a whole is this. Well, and this is like one that we talked about with limits as well. What happens if you're taking the derivative of a sum or a difference of two functions? So let's say you have an f of x plus g of x. What happens if you take the derivative of that sum? And what you actually end up getting is you end up getting the derivative of f of x plus the derivative of g of x. So this actually should work exactly the way that you want it to work, which is the same way that it worked with limits, so that we don't actually care. If we have a sum here, just take the derivative of each of the separate terms separately and then add the result together. This doesn't just work with addition, it works with subtraction as well. So I'll put plus or minus in there. Now, you may remember this, but back when we talked about limits, I gave you a really big warning, and I said, hey, with multiplication and with division, this same thing works for limits, but I said it will not work for derivatives when we get there. That's actually going to be our next section of material. What happens when we talk about multiplying or dividing two functions? You cannot do the same thing with multiplication or division. And honestly, I don't know if I could say it enough times for that to just still stick and to sink in for a lot of students. Like, we cannot do the same thing with multiplication and division, but you can with addition and subtraction, is that you can just take the derivative of the two functions separately when they're added and subtracted together. Okay, so based on this, we can use a few of these rules together to talk about all polynomials, not just a power function, but all polynomials. Here's what that would look like. I tell you what, let's look at the rules that we need first. We first of all need the power rule, which says that when you have x to the n and you take its derivative, you get n times x to the n minus 1. We also need a rule that says that when we take the derivative of c times f of x, that we get c times f prime of x. And then we also need a rule that says that f of x plus or minus g of x, when you take the derivative of that one, you get f prime of x plus or minus g prime of x. So these are three of the rules that we have already talked about so far at this point. And now we can talk about putting all three of these rules together. For example, to say something like, if f of x is 2 times x to the third plus 7x squared minus 5x plus 4, what does f prime of x look like? Okay, so we can kind of go piece by piece in this, and when we get a little practice, we're going to get really quick at this. In fact, some of you might already be there. Where we should get to, and you might be able to even just look at this and say, oh, okay, cool, that makes sense, or I see how we got that. We're going to get to something where we're going to be able to quickly say, oh, you know what, that's just 6x squared plus 14x minus 5. And that's what we should get as our answer. But I want to kind of break this down piece by piece, just at least in this first example, to see how we would deal with a polynomial. And so when we take the derivative of this whole function f, remember we can take the derivative of each of those four terms separately. So in other words, we can say what is d over dx of 2x to the third? And then, okay, great, what is d over dx of 7x squared? What is d over dx? Well, I guess it's minus there, isn't it? So it doesn't really matter if it works for plus and minus, okay? So then minus d over dx of 5x, and then plus d over dx of 4. Okay, so kind of break it down piece by piece. So by doing it this way, we're using kind of this third rule up here that says, okay, you can split it up and take the terms separately. Now we have a few different places. I see 1, 2, 3 in here where we have that constant c multiplied out front. And in all of those cases, you can bring that constant out in front of the derivative. So this becomes 2 times the derivative of x to the third. And you don't need to write these steps out every time, but I just want you to know kind of where they come from. I don't want to jump all the way to the end and then you say, well, where did that come from? How did we get there? If you can do that, great. But at least once here, I want to look at kind of what are the details of why this all works. So for the second term, you can pull that 7 out front and then times d over dx of x squared. And then minus, pull the 5 out front, and then times d over dx of just an x. And then the last one there is just the derivative of a constant. You remember what the derivative of a constant is, right? Even though I didn't write it on the top of the page. Derivative of a constant is always 0. And so then you can use the power rule here to take the derivative of x to the third and x squared and x. And so notice where the 6 comes from, 6x squared on the bottom. It comes from the 2 out in front times the 3 as an exponent that's going to be down in front. So this is 2 times 3x squared, and then 7 times, let's see, the derivative of an x squared here is going to become a 2x, and then minus 5. What was the derivative of just an x again? Oh yeah, that's just a 1. Okay, and so that's where your 6 and your 14 and your 5 come from right there. Again, you're going to get really quick where you don't need these middle steps, but I just want to see, hey, what are the rules behind those and why are we allowed to jump kind of to the end? And you'll hopefully get pretty quick saying, oh, you know what, the 3 drops down, multiplies by the 2 drops down, multiplies by the 7, and we'll get pretty quick with these. Okay, so that is how you can take the derivative of any kind of a polynomial, and this actually works as well even if you don't have whole number exponents. So to give you a little bit of practice with this, and because I said this doesn't work, or that this works even when you don't have whole number exponents, let's look at one more problem in here. So f of x equals 5x to the 7th minus 3x to the 3rd plus 2x to the 3 halves plus, I don't know, 4x to the 0.7 power. That's a little weird, but that's okay. You could write it as 7 over 10. It's like raising to the 7th power and having a 10th root. Again, you want to be able to be really comfortable going back and forth between fraction exponents and negative exponents, and what do those mean? Okay, so if we had this as our original function, could we find the derivative? Okay, and so again, we're going to have, if you're just starting out, you've never seen this before, I would recommend you having kind of one middle step. Here's maybe what that middle step would look like. If you are okay jumping to the very end, that's perfectly fine. F prime of x here, I'll tell you the final answer first, and then the middle step that you might want to put on there if this is new to you. The final answer, you're going to get something like 35x to the 6th minus 9x squared plus 3x to the 1/2 plus 2.8 x to the negative 0.3. Okay, so that's kind of what your final answer is going to look like. Now, how do we kind of get there as a middle step if you've never seen this before? I would recommend this. Your 5x to the 7th, just write the 5 and then write the 7 that's going to drop down in front, and x to the 6th power. So like dealing with that 7x to the 6th separately as a power rule, and then leave that 5 out front. And then, oh yes, 5 times 7 is 35. And then with the next one, leave the 3 out front. That was already there. And then, okay, now the 3 is going to drop down from the exponent, and we're going to have an x to the second power, okay? And then, okay, the next one is going to be a 2 out in front times 3 halves drops down, and x to the 1/2 power. And then, oh, the 4 out in front, and then 0.7 drops down, and then, okay, 0.7 minus 1, that's negative 0.3. Okay, and so by the way, the fact that we have a negative exponent in here, this also works for negative exponents. I could have thrown a negative exponent in there. Be pretty careful when you have negative exponents because you're still going down by a power. Okay, and sometimes when we throw in negative numbers can just kind of trip things up a little bit. We can struggle with those a little bit. So if it helps you to actually write up in the exponent whatever the original exponent was, and then minus 1, and combine them together to figure out what your new exponent's going to be, go ahead and do that, okay? Take any precautions, any steps you need to as middle steps to make sure that you can feel comfortable with this. I would recommend going and practicing this a lot, and we're going to be seeing a whole lot of this. Okay, so in the next video, go ahead and check out the next video that's going to talk about finding derivatives of exponential functions, and I hope you've enjoyed. Good luck practicing.